How do we describe how position changed? You started out class today with a reading quiz. If you were absent today, don't worry, you'll be marked as excused. Okay, so as a reminder, we discussed what we needed to describe position. We need a reference point or an origin, and we need some sort of system to describe where we are in relation to that. That could be a coordinate system, that could be the cardinal directions, north, south, east, west, and we need some sort of scale on that so we know the actual numbers. Okay, you worked in groups and you drew a treasure map within the classroom. You wrote a set of directions to give to another group. Then you switched with the other groups. You followed the directions, and when you got to the X marks the spot, you determined how far you had traveled and how far you were from your starting location. All right, and then what did we notice? We noticed that how far we had traveled was always a bigger number than how far we were from where we started. And sometimes we ended up back where we started. So these were both distances, right? But maybe they had different meanings. So you worked with your table group to determine a word to assign to each of these definitions. One, the path you travel, all right, and then the other one, where you ended up. So we had two definitions and we were looking for vocab words. We weren't necessarily looking for physics words or math words. We just wanted descriptions. So then we shared them out, and sometimes they were a little more scientific and sometimes they were very descriptive. And then I shared with you the physics words, all right, distance and displacement. Distance is the actual path traveled. So to find it, you just take each leg of the journey and you take the magnitude, all right, the length of that leg. All right, so one way you could think of this is the absolute value. Okay, so we're not worried about the direction. You just add up how far you went. This is like the odometer in your car, which just counts up how many miles you've driven. All right, so it's always going to keep increasing. It will never decrease. Okay, so distance has no direction. Okay, so it's always going to be a positive number. Okay, this is what we're going to call a scalar when we start talking about scalars. Displacement has a very special, specific meaning in physics. Displacement is the change in position. Okay, this one does have a magnitude and a direction. This is what we're going to call a vector eventually. Okay, so this means that displacement can be a negative value. Okay, so if this is the change in position, okay, when I gave you the quick reference sheet, the delta, that triangle symbol you see down on the third bullet point, that's delta. That means change. Okay, so if displacement is the change in position, all right, we're going to write that as delta x. Okay, because in this case we're going to use x for position. You could use y, but we'll stick with x for right now. Okay, so that is defined as being the final position minus the initial position. Okay, so that's where we start seeing subscripts. So x subscript f, we're going to say is x sub f, or just xf. Okay, so this one's easy. The f is for final. Okay, and then it's minus x with a 0 for a subscript. All right. You might see this sometimes as an xi for initial, but the AP test uses a 0, so that's what we're going to use. In this case, you would say it x naught, N-A-U-G-H-T. Okay, so we did a quick check to make sure we were on the right track. If a cyclist rides 3 kilometers west and then turns around and rides 2 kilometers east, her displacement is 1 kilometer west. All right, she's 1 kilometer west of where she started. Here, the direction is important. Okay, so you need all three parts. The 1 for the number, kilometer for the units, and west for the direction. For B, what distance? She rode 5 kilometers. If she had turned on her little fitness app when she started and then stopped it when she finished, it would show that she rode for 5 kilometers. Okay, for part C, what is the magnitude of her displacement? Here, we're just looking for the numerical part of the answer for displacement. So for part A, the answer was 1 kilometer west. For part C, we just want the 1 kilometer piece. Okay? Now, got to keep the units in there, but you can ignore the direction if you're talking about magnitude. Okay, here's the daily summary. Distance is the total path traveled. It's always positive, all right, and it can be larger than the magnitude of the displacement, or it can be the same if you just went in one direction. It will never be smaller than your displacement. Okay, displacement is the change in position. It is always final minus initial, and it can be negative. Okay, also don't forget it has a magnitude and a direction. And since this is the first time we've seen the delta symbol, okay, it is the symbol for change in mathematical notation. In physics class, it will always be used to denote the final quantity minus the initial quantity. Your homework is to watch the vector video that is also posted on today's post, and to read sections 2.1 and 2.2 in OpenStax. Now, this runs from page 36 to 39, so you've already read a couple of pieces over the weekend. Don't forget your project is due on the 25th, next Thursday, and mastery quizzes are still open. There will be a vector mastery quiz coming soon, exact date to be announced in class. You finished out the day by writing in your notebook what you learned today. All right, hopefully you discussed the difference between distance and displacement and how you will remember the difference. Please go back and review what you wrote, okay? And if you have a clever way of remembering the difference, please let me know and I will share. And if you want to remain anonymous, that's fine too.